Hi. So let's talk cooker hoods and servicing misdemeanors. We're talking about a Ireland cooker hood extractor, stainless steel, thing of great beauty, I have to say. Up there in the sort of, I don't know what the brand is, can't remember, but it's up there with Miele and those sort of posher brands with perceived real quality and the price to match. And in each corner, so you can see your pan of highly nutritious porridge first thing in the morning, there's one of these little light fittings, which are also gorgeous. I mean, they're beautifully made, and they just clip into holes on the surface of the downward facing surface of the cooker hood. But they have a reputation and history of failing. So on one occasion, somehow or other, a engineer visited the house and spent some hours with a soldering iron sorting the problem out. I just can't quite understand why to change lights or bulbs or whatever, the soldering iron comes out. So anyway, I had a look, and the power supply is giving these LEDs 20 volts. That's the actual LED there, that tiny little yellow speck in the middle, which sits on this little aluminium board, which is also a heat sink because they do get a bit warm. The actual LED component. Here we go, there's one. I mean, it's so small it would probably be difficult to see it. That's it. They want and require a maximum, absolute maximum, of 4 volts, and yet the power supply is lobbing out 20. So what this engineer's done is wire them in series like Christmas tree lights. So you've got 4 lamps at 4 volts, 4 4 16. So the whole thing actually wants 16 volts, and yet it's getting 20. So he must have done that as a bodge, fully in the knowledge that they were being overpowered and they would fail early. So the obvious thing to do is give them the voltage they want, and I've elected to do just that. One of these cute little boards, courtesy of China. Again, it's difficult to convert DC voltage from any voltage to a lower voltage, except for these. And these are actually adjustable as well, so we can tweak these to any voltage you like and effectively get from maximum brightness down any brightness we want out of these little lights. Thinking about it as I've been working on these, it's likely that somewhere in the power supply, I mean 20 volts is a really obscure figure to start with. I don't know quite where that's come from. Maybe the fan motors on the extractor side are 20 volts, don't know. But the display and the touch control bit is going to be 12 volts, 5 volts, something like that. Certainly not 20. So I think 20 volts is where they start, probably because of the fan motors. And then there's every likelihood there's things like that in there to give other sections of the device the voltage they want. As I say, the touch control and display is probably going to be 1 voltage, and the lighting should be 3.5 to 4 volts really. So maybe there is actually something like that buried in this semi-sealed power supply, which has gone bang, and the engineer couldn't be asked, or didn't want to, or whatever, get into replacing that. It may mean replacing the whole power supply, who knows. So he did the bodge where he wired them Christmas tree lighting style in series, fully in the knowledge that they would only need 16 volts to work, but were being given 20. Interesting. So here we are. all 4 of these are being replaced with new LEDs, as we have had to drop the power of the LEDs a bit to get a sensibly priced voltage converter board. So they've gone down from 3 watts to 1.5. That's half the amount of power, officially half the amount of light, but actually these are still extremely bright, easily bright enough to be able to see what's going on in your frying pan on a cold winter's evening at 6 or 7 o'clock. Yesterday, quite late in the evening, I just couldn't help myself but have a play to see how the new LEDs that I managed to find would work, and took one of these apart, put a new LED in, worked, ran it for an hour or so to make sure that the voltage regulation board didn't get hot, to make sure that these didn't get hot, and so now I've been doing the other 3, and this is number 4. They are a pig to get the old LEDs out, because they're surface mount. So the tiny, and I mean tiny, these tiny little pads of thing here, they're the connections, and they mount directly on the surface of the seam surface of the board. So prizing them off is interesting. It's dental tools, nice clean soldering iron. At this point I need to put my glasses on. There we go. I can actually see what I'm doing now. On that first one I did last night, I discovered you can just get in underneath the connection tab and then get onto the solder. Just takes some doing. There we go. One. This board that they're mounted on is aluminium, so that tries to steal all the heat from the soldering iron, just to make life interesting. Oh, look at that! Can't get this one out. Oh, there we go. Right, warmy, warmy, warmy. See if this takes forever to melt this solder, because there we go. That's cool. Then you have to get a bit brutal, which is rather interesting. I actually bent the first one doing this, I will admit. Managed to recover it. But you have to essentially beat the shit out of it with a hammer to get the old LED off, because it's stuck in place with a heat transferring goo-goo compound. And half of it's come away. There we go. Go. Oh, I think I've managed to bend that one a bit as well. Yeah, slightly. We'll be okay. So, sling that back in the vise. Another thing I did last night was mark which end of these was positive with a little red dot. As that only work in one direction. The famous pop band. That looks like it's all going to line up. We'll just put a little dob of solder on the tabs. To ease their passage into installation out to that spot. I seem to have a load of crud on the end of my soldering iron again. Surface mount, unlike older technology, there's no holes on the printed circuit board to put legs through or anything. This is all a bit hopeful. I think that's connected. There's only one way to find out. here I have a nice little DC voltage wing down here, so I can temporarily lob this in here. Send it a bit of voltage and see if it works. Actually, no, I think it's the other way around. I'll stab that in there. Just connect up there. I'm actually using 12 volts. It's what I've naturally got in the workshop, but because the little voltage board is adjustable, it doesn't matter that we're going to be feeding it 20 low, so we're just turning the output voltage down on that. Yeah, really. Ridiculous, right. So that's fine. All we have to do now is put this back together. I've had the actual body languishing in a ultrasonic cleaner, which is meant for jewellery really, but it got all the crud, a bit of you know, steam and oily steam and stuff hits them. So it's got all that off. I'm just going to go and retrieve that from the cleaner, and then we'll put the thing back together and connect up all four and test them as they would be in real life. So here we are with the body of the doodah. We've got this little lens which sits in there. There's a dimple on the inside which the LED sort of squishes into when it goes on there, and that's what forces the back of this onto this aluminium screw-in plate, and that is what dissipates the heat. So the heat comes off the back of the diode itself, gets shunted into this screw-in bit, and this can be fun. One of these things where everything wobbles around until it's all in one piece, and not the easiest thread to start either. Oh, here we go. So I have to do this up quite tight, and then the dimple on the back of the lens pushes the LED in, so it really makes proper sort of thermally good contact with the that back plate. And because that back plate's screwed into the fitting itself acts as a bit of heat exchange, and when that's plugged into the underside of the unit, the whole unit and its enormous stainless steel case also acts as heat dissipation. Right, I'm going to leave you for a second while I just wire all these up together, and we'll go for the big bang test. So I've cobbled all these together in parallel, so now if one stops working, they won't all stop working, just the one that stopped working will stop. And they've got the correct voltage on them, supplied by this little baby, which I'm in love with. Brilliant little thing. So I'm about to connect the supply to the voltage regulator. At this point there may be a bang, it might all work. Either way, I'm going to light a cigarette. Here we go then. Hurrah! Look at that. Okay. Permanently connect that, and I'm going to leave it running for some hours to make sure nothing gets hot and make sure everything's happy. But there we go. Actually, it'd be interesting to read the voltage. Let's have a look. I don't know if you'll be able to see what the meter actually says. Ooh, it's fun to get into. 3.5 volts, which is what I set it to. So with just one LED running, it's still exactly the same. So I've got a flickery LED here, that's my dodgy connection on it. So the moral of the story, I guess, is trust no one. And once again, all we want is people to do their job.